Hi, Algebra 2. This is Unit 4. I divided the packet up into two sections, so this is the second section. This is Lesson 4.8, and today we're going to start to talk about logarithms. A logarithm, we abbreviate it log, is another way of writing exponents. Basically, it's the power to which a number must be raised in order to get some other number. We use logs to solve for exponential equations. But we first need to understand exactly how this works. So we're going to practice converting logs to exponents and converting exponents to logs. So a logarithmic form is log, base b. So this number that's written a little bit lower as a subscript is base b of a equals x. What does that look like in exponential form? Basically, it would be b to the x equals a. So the number on the right, that x, is actually the exponent. The base b, so we got b is the base. The answer is the exponent equals a. So the logarithm is the power to which a number must be raised in order to get some other number. So the answer is that exponent or that power. So let's practice doing some of these just to make sure we have an understanding of this. So we'll start by converting logs to exponents. So if I have log base 3 of 9 equals 2, that really means 3 to the second power equals 9. So the number out here is the exponent. The answer of the log is the exponent. That's what's different about them. Log base 6 of 216 is 3. 6 to the third power is 216. Log base 7 of 1 equals 0. 7 to the 0 power equals 1. Log base 2 of 16 equals 4. 2 to the fourth power equals 16. Log base 4 of 116 equals negative 2. 4 to the negative 2 power equals 1/16. Log base 9 of 27 equals 3 halves. 9 to the 3 halves power equals 27. Okay, let's go back the other way and convert exponents to logs and get a little bit better understanding of this. This is brand new. It's a weird concept. Okay, so if I had 4 squared equals 196, 14 squared equals 196. It's a log. The base is a subscript written down here, log base 14 of 196 equals 2. The exponent is my answer. For number 8, log base 3 of 81 equals 4. It's very different logs, and we'll eventually get to, when they'll be used. 12 to the first power equals 12. Log base 12 of 12 equals 1. 36 to the 1/2 power equals 6. Log base 36 of 6 equals 1/2. 2 to the negative 3 equals 1/8. Log base 2 of 1/8 equals negative 3. And the last one, log base 8 of 16 equals 3/4. All right. Flip this over. Now there's something called the common logarithm. The common logarithm is when you press the log key on your calculator, that's the common logarithm. It's a logarithm with base 10 is called the common logarithm, and we can write it without the base. So the log base 10 of x, we can just write as log of x. So if there is no base, it's assumed that it is base 10. So let's use our knowledge of exponents to evaluate the following logarithms, all right? So log base 7 of 49. Basically, this is saying 7 to what power equals 49? Well, 7 to the second power equals 49. Okay, so this would equal 2. Log base 3 of 27. That's saying 3 to what power is 27? Well, 3 to the third power is 27. These I can do in my head. Log, I don't have a base. Remember, if there's no base, it's base 10. 10 to what power equals 100? Well, to the second power. Now, base 10 I can do in my calculator. So if I go to my calculator and I hit log of 100, I'm going to get 2 as my answer, just like I did. All right, log base 12 of 1. That's saying 12 to what power equals 1? Well, that would be to the 0 power. Okay, I'm thinking of these as exponents for now. Log base 2 of 64. 2 to what power is 64? 2 to the 6th power is 64. 3 to what power is 243? And you might have to do this in your calculator to check it out. And just do 3 to the 3rd power, 3 to the 4th power, 3 to the 5th power. Actually, to the 5th power is 243. 9 to what power is 1 over 81? Okay, 9 to the negative 2 power is 1 over 81. And 64 to what power is 4? Okay, the way that I'm going to make it smaller is to have a fraction. So 64 to the 1/3 power. Basically, you're taking the cubed root of 64, and that equals, whoops, my pen's not writing. Let me move this up a little bit. Yep. Okay, I think I used my pen too much today, and it's running out. I got to charge it. X is 1/3. All right, let's actually practice solving some of these. Now, as I said, your calculator is just in base 10. Well, I'm not going to always have a log in base 10, so we have a change of base formula, okay? So the way the change of base formula works, some logarithms are not as easy to evaluate as the ones above, because I can't see it in my head. The ones above, I could see everything, I could figure it out. But ones that are more difficult require a change of base formula. So if I have log base b of a, I do the log of a divided by the log of b. Okay, log of a divided by the log of b. So if I have log base 16 of 64, basically I'm saying 16 to what power is 64? There's no number. It's going to be a decimal, so it's impossible to figure out in our heads. All right, so the way I use my change of base formula, log of 64 divided by log of 16. That I can do in my calculator. So I go to my calculator and I do log of 64, log, there's my log button, of 64, hit the right hour to get out of the log, divided by log of 16. 1.5. You could, 1.5 is not terrible, but you don't want to keep on using your calculator to try and guess and figure out what it is. So this is 1.5. Done. Again, this is saying 8 to what power is 32? There is no number, it's a decimal. Change of base formula, log of 32 divided by log of 8 will give me the answer. So log of 32 divided by log of 8. All right, and I get 1.6 repeating. Right, if I was to do 8 to the 1.66666 power, I would get 32 as my answer. Okay, you can check your answer if you want to. This one's a harder one to check because it's a repeating one, but I'll show you another one that we can check. So this was 1.6, but it was repeating. Okay, log base 2 of 54. 2 to what power is 54? It's going to be a decimal. Log of 54 divided by log of 2. Log of 54, try these with me so you're okay doing them. Log of 54 divided by log of 2. and I get 5.75488. All right, this doesn't say how I'm going to round them off, so I'll just write a couple of decimal places. All right, hopefully you're getting the idea of this. So I get 5.7549. Okay. Log base 10 of 294. Now this one's base 10, so you can actually just do log of 294 in your calculator. But if I'm doing my change of base formula, it's log of 294 divided by log of 10. Okay, so log of 294, log of 294 divided by log of 10. And I get 2.4683. What happens if I just did log of 294? I get the same answer because the calculator uses base 10. So I don't have to use the change of base for that one if I don't want to. Okay, so I get 2.4683. Just writing a couple decimal places there. And then this one right here. So log base 4 of 136, change of base, log of 136 divided by log of 4. Log of 136, log of 136 divided by log of 4. And I get 3.5437. You'll be told how to round this off. 3.5437. Okay, and this one you might be able to do in your head, but just use change of base. Log of 1 over 36 divided by log of 6. So if you ever don't, or you're having trouble figuring it out, some of the easier ones, you can still use this. So log of 1 divided by 36 divided by log of 6. And that gives me -2. Okay, so basically 6 to the -2 power is 1 over 36. All right, so that is -2. Between what two consecutive integers must log base 3 of 40 lie? So basically that's saying that 3 to what power is 40? All right, it's between two integers. So 3 to the third power is 27. 3 to the fourth power is 81. And I don't know why this isn't writing. 3 to the fourth power is 81. So log base 3 of 40 is in between 27 and 81. So basically it lies between 3 and 4. Now if you wanted to actually find the real answer to it, you would just do my change of base. Log of 40 divided by log of 3. So log of 40 divided by log of 3. And it's 3.357. See how it's between 3 and 4. But you can use your calculator for that. And last one. If a function y equals log base 2 of x plus 8 plus 9 was graphed in the coordinate plane, which of the following would represent its y-intercept? Remember that the y-intercept is when x equals 0. So we basically have log base 2 of 0 plus 8 plus 9. All right? So this is saying 2 to what power equals 8, okay? But I'm going to, and 2 to the third power equals 8, so basically x is 3, but then I am adding 9 onto it. See how this 9 right here gets added on. So let me just get a different color pen so you guys can see what happened. So this was just 8, so I'm just figuring out this without the 9. All right, 2 to what power is 8? 2 to the third power, and now I'm adding on the 9 so that my y-intercept is going to be 12.